All right, we are ready to finish up 3.5. I don't think we talked about even, odd, or neither in class. I'm looking for my notes, you know how I am. Oh, for goodness sakes. There they are. All right, so to determine if a function is even, odd, or neither. Even functions are like x squared, x to the fourth, x to the sixth, x to the eighth, and so on. If you remember, x squared makes a parabola like that. X to the fourth just makes a wider bottomed parabola. As the degree gets higher, as the power gets higher, the fatter they get at the bottom. Odd functions, and I should tell you this, even functions have y-axis symmetry. So if we scoot this thing to the left or the right, it's no longer even. Odd functions have origin symmetry. They look like this, like x cubed. This is x to the fifth. It just gets a little wider at the bottom. Neither has no symmetry. So how do you tell if a function has even, odd, or neither symmetry? Well, I'll just give you some examples. Let's try a couple. Let's say I have y equals 4x to the fifth minus x. Can you see that? This is so frustrating. Let's do y equals negative 2x to the fourth plus x squared minus 8. To figure out which kind of symmetry it has, plug negative x into x. Simplify. All signs change is odd. All signs stay the same. Is even. Only parts change. Is neither. So if I put negative x up here for this guy, I get 4 times negative x to the fifth power minus negative x. Well, a negative to an odd power just makes it negative x to the fifth. That becomes plus x. So it's negative 4x to the fifth plus x. Comparing it to the original, see how the first term became negative, the second term became positive, so everybody changed. So that function is odd. Here, we'll do negative 2 times negative x to the fourth power plus negative x squared minus 8. Well, negative x to the fourth power becomes positive x to the fourth. Negative x times negative x is positive x squared minus 8. So it's negative 2x to the fourth plus x squared minus 8. Comparing it to the original, everything's changed, or everything stayed the same, therefore it's even. So if I do y equals 3x plus 2, if I put negative x in there, you get y equals negative 3x plus 2. Comparing it to the original, the first terms changed, but the second term didn't. Therefore, it's neither. All right, so that should take care of the rest of 3.5.